Hello everyone. In this video I'm going to explain what radicals are. I'm going to start with square roots and generalize the concept to all radicals. So what is the square root of a number? Well, the square root of a non-negative number a is another real number b, so that if b is multiplied by itself, it gives us a. For example, if I multiply 5 by itself, it gives me 25. So we say that 5 is a square root of 25. If we also multiply negative 5 by itself, it also gives us 25. So negative 5 is another square root of 25. This means for any positive numbers, we will have two square roots, positive and negative. Regarding the notation, this is how we represent a square root. This sign is called the radical, and the number underneath the radical is called the radicand. And the entire thing is called a radical expression. So for example, the square root of 100 is 10, the square root of 6 to the power of 2 is 6, and the square root of negative 6 to the power of 2 is equal to 6. It is not minus 6. So that's a common mistake. In other words, I cannot say that the square root of negative 6 to the power of 2 is equal to minus 6. That's wrong. Why? Well, simply, the sign of the left side is positive, and the sign of the right side is negative. So it is not possible to say that a positive value is equal to a negative value. Now, let's go back to this expression. So the square root of 100 is equal to 10. If the square root of a number happens to be an integer, we say that this number is a perfect square. So 100 is a perfect square because 10 to the power of 2 is equal to 100, and 10 is an integer. Another example is the square root of 81 is equal to 9, which means 81 is also a perfect square. Now what if I have something like the square root of 72? Now 72 is not a perfect square. In this case, we try to write it as a product of factors where some of the factors are perfect squares. So 72 is equal to 36 times 2, and 36, in this case I can take it out and it becomes 6. 2 is left underneath the radical. Now what are the properties of a square root? We start. The product of two square roots is equal to the square root of the product. So for example, if you have the square root of 5 times the square root of 6, we can write it as the square root of 5 times 6, which is the square root of 30. Same thing for the quotient, but this does not apply for the sum and difference. And I'm going to give an example. Let us compare the square root of 25 plus 144 and the square root of 25 plus the square root of 144. In the first expression, we first add. So 25 plus 144 is 169, and this is a perfect square, which gives us 13. For the other expression, we perform the square roots first. So the square root of 25 is 5, plus the square root of 144 is 12, and the sum is 17. And as you can see, the answers do not match, which means the square root of the sum is not equal to the sum of the square roots. This property is really very important. If we have the square root of a squared where a is anything, we cannot say that the square root of a squared is equal to a unless we know that a is positive. If we are not given that a is positive, we must add an absolute value. And I'm going to return to the example, which is the square root of minus 6 squared. We said that it's equal to 6. Why? Because applying this formula, it is equal to the absolute value of negative 6, which becomes 6. Now let us move on to the general radicals. If there exists a number b, where a is equal to b to the power of n, we say that b is nth root of a. So for example, we have 4 to the power of 3 is equal to 64, which means that 4 is a cubic root of 64. So that is the generalization of the concept of radicals. So this is the notation for a general radical. And the number here at the top is called the index of the radical. So for example, since we have 5 here, we say that this is the fifth root of negative 32. as well as this, the fourth root of 625. But what about the square root? Does this mean that it does not have any index? Well, the answer is no. The index is 2, but when the index is 2, we do not need to write it. It is by default 2. Regarding the properties, we have the same properties as the square root. So the product of the nth roots is the nth root of the product, provided, of course, we have the same index. If the indices are different, we cannot multiply. For example, the cubic root of x multiplied by the cubic root of y is equal to the cubic root of x times y. This also applies for the quotient, where the two radicals again have the same index. What if we have two radicals on top of each other? So we can convert this expression into a single radical, but of course the index will change, and the new index will be the product of the previous indices. For example, if we have the fifth root of the third root of some a, that is equal to the 15th root of a. These two properties are important. So in general, if n is even and I want to take out a factor outside the radical, I must apply the absolute value as we said in the square root. It is not only for the square root, it's for any radical with an even index. So again, for example, if you have the sixth root of x to the power of 6, that is equal to the absolute value of x. Unless we know from the question that x is already positive. However, if n is odd, we do not need an absolute value. Now let me sum up all the cases of the radicals for n real number a and a positive integer n. So if a happens to be positive, then if n is even, a has two nth roots, positive and negative. However, if n is odd, we only have one nth root. So for example, if we consider 16, we know that 16 is equal to 2 to the power of 4 as well as negative 2 to the power of 4. Now if you consider 32, for example, 32 is only 2 to the power of 5. It is not equal to minus 2 to the power of 5, which means 32 only has one fifth root, which is 2. Now the second case is a negative. If a is negative and n is even, then we have no real roots. For example, if I try to find, for example, the fourth root of negative 16, that's not possible because there is no number whose power of 4 is negative. Again, as we said before, minus to the power of even is always plus. So if n is even, no real roots exist for a negative. But if n is odd, that is possible. For example, we might have something like the fifth root of minus 243. And this is possible because we do have a number whose power of 5 is equal to negative 243, and that's minus 3, because minus to the power of odd is minus. Finally, if a is 0, of course, no matter what n is, whether it's odd or even, the nth root of 0 is always equal to 0. One last thing I want to say here in this video is how to convert from a radical expression to an exponent expression. So the nth root of a to the power of n is equal to a to the power of m over n. So for example, if I have the fourth root of 2 to the power of 3, we can write it as 2 to the power of 3 over 4. And if we have the square root of some x, provided x is positive, this is equal to x to the power of 1 over 2. Why? Well, because it is x to the power of 1, and we said that the index is 2 by default, so it is 1 over 2. So that's everything regarding radicals. In the next video, I'm going to solve some exercises on how to simplify radicals, as well as how to rationalize the denominator of a fraction.